Good morning, everyone, and welcome to the webinar, A Match Made in Coordinates, bringing Revit, Civil 3D, and InfraWorks, together at last. My name is Sarah Snavely from Timmons Group, and I will be moderating today's session. This program will be provided via both audio and web conference and will last approximately 45 minutes, followed by a Q&A session at the end. If you have questions at any point during today's presentation, you may submit them at the bottom button, or the Q&A button on the bottom of your screen. Please note one quick mention that we will be submitting today's credit directly to AIA, and we will be sending all attendees certificates of completion via email, so be on the lookout for those. And now it is my pleasure to introduce today's speaker, Donnie Gladfelter, Donnie Gladfelter.
Too early, right?
I'm tied there. Go ahead, take it away, Donnie.
All right, excellent. Well, thank you, Sarah. And once again, welcome to our presentation today. A Match Made in Coordinates, bringing Revit, Civil 3D, and InfraWorks together at last. So this, of course, I think has become a very pressing sort of challenge question, especially as the sort of architecture and building discipline worlds have sort of departed from the civil world, where civil is still AutoCAD based, whereas all of the building disciplines we know are, of course, Revit based. And while there are advantages to both sides for each discipline, it does create this gap between the two worlds. And so that gap is the specific thing that I'm focused on, that I'm going to try to answer some questions on today. And so with that in mind, let's get the clicking thing working here. So with this, the basic foundation of that gap, kind of where does it exist? And it really centers around points. The way that Revit manages coordinates is very different from the way that Civil 3D manages coordinates. And so we have to find a way to sort of manage and bridge that gap. And so we're going to talk first about kind of what is the problem. How does Revit see the world? How does Civil 3D see the world? And then from there, we'll take a look at kind of the solution itself. And it's going to combine a number of different tools. And so we'll talk briefly about what those tools are before kind of rolling up our sleeves a bit and jumping into the software and seeing how we can actually put all of this to work. As Sarah mentioned, we do encourage your questions throughout the presentation today, so feel free to enter those into the questions pod. We'll certainly address those at the end of the presentation, as we do have quite a bit to get through here. There's a number of tools that we have to bridge or that we have to leverage during today's presentation. So as Sarah mentioned, my name is Donnie Gladfelter. I am the Design Technology Manager here at Timmons Group. So my focus is on all of our production teams and making sure that they have the resources that they need to be most effective kind of in the design roles that they have, be that obviously designing civil sites or as we're focused on today, how best to collaborate with external clients, specifically architects and other building engineers. So my resume includes quite a bit of different things. Actually, today's presentation was a top-rated session at Autodesk University a couple of years ago. Autodesk University, for those who might not be familiar with that, is the biggest sort of Autodesk user conference that happens every year. I'm also an author of 6 books, was recognized as a top 35 young designers under 35 by Autodesk, and also an Autodesk Expert Elite member, which is a small group of individuals hand-selected by Autodesk for their software expertise. So I'm excited to share some of that with each of you today. So with that in mind, as we take a look at kind of what today's presentation is going to look like, there's a number of things that we're going to do. First, a big part of the presentation is going to focus on coordinates, and more specifically, shared coordinates. How can we establish shared coordinates between Revit and Civil 3D, two very separate worlds? And then once we kind of center those two worlds together, it begins opening up, I think, a lot of really exciting opportunities in the way that we're able to exchange information back and forth. So anything that's in Revit, we can very easily bring into Civil 3D. And in a similar way, anything that's in Civil 3D, we can also bring into InfraWorks. And now that we have this sort of reconciled model, we can start assembling it to do other, I think, exciting things, such as visualization inside of other tools that you may or may not be familiar with, such as InfraWorks. So with that in mind, as I mentioned, we have a lot to get through here. So I don't want to waste any time as we dive into things. But as I mentioned, one of the sort of central struggles that we have here centers around points. And so I'd like to make a point about points, otherwise known as coordinates, of course, in our world. So as a little bit of a riddle to get us started. I'm sure we have many architectural clients on the line here today. I imagine that everyone is probably familiar with this building. This, of course, is the Burj Khalifa. It's currently recognized as the world's tallest building at 2,722 feet tall. Now, I understand that the design of this is more of a pyramid, an elongated pyramid shape. But if you can kind of play along with me here for a moment and imagine that all of the corners of the building were perfectly plumb. Following along? My question to you is, if all corners of the building were perfectly plumb, how much wider would the top floor be than the bottom? Now, this is kind of a curious question because when we think about plumb, we think about things being straight up and down, and they are, except they're straight up and down to the center of Earth. And so if we expand that out over a wide, footplate, like the Burj Khalifa has, what we end up with, obviously exaggerated here a little bit, is not a square or rectangle where all corners are 90 degrees, but rather something more like a trapezoid. And so again, the reason for this is plumb is something that is relative to the center of Earth. And so as we get out from a certain point, that is going to, again, form more of a trapezoidal shape. And so this is kind of the inconvenient truth of what we do as design professionals. The reality, of course, is that the world is not flat. And because of that reality, in a certain way, every plan, every map that we've created is a lie in a certain sense. That's obviously not a comfortable thing to think about. The good thing is we all agree on what that lie is. And of course, lie is maybe a strong term. Margin of error or tolerance is probably the better term here. And so with that in mind, as we take a look at how we address this on the civil side, again, we create models too, but everything that we do is going to be projected to a geographic coordinate system. Now, the prevailing system that is still used today is something known as the North America Datum of 1983. It's been updated a few times. There's actually some new datums getting ready to come out. And again, this is kind of the map of the United States, all of the various coordinate systems. And what this allows us to do is to slice up the Earth into small enough pieces that the tolerance or the curvature is within an acceptable, tolerance. And so depending on where a project is, it will be projected to one of these coordinates. And this is what we refer to as real world coordinates. And we typically express this in a relationship of northing and easting to get the precise location on Earth. So this is how Civil 3D and its projects are going to be set up. Now, this starts to introduce the true kind of struggle or the tension that we have here as we try to begin working with Revit. Because in Civil 3D, the world kind of revolves around the project. The project is where it exists in the world. In Revit, the project or the world really needs to revolve around the model. The model needs to be where it is, and the world can revolve around it. If I were changing a light bulb in Revit, I would stand in one place and let the world turn around me. And one of the big reasons for this, one of the big practical reasons for this is the fact that in Revit, the world is only about 20 square miles, oftentimes a bit less than that even. 20 miles is certainly the outermost extents of a Revit project before bad things start happening inside of our Revit models. And to somewhat help us with this, we do have a number of different base points. And this is another area that is, of course, one of the big divides. In Civil 3D AutoCAD, we have really one base point. It's the 0, 0 coordinate of the drawing. But in Revit, we actually have 3 base points. And most folks are very familiar with at least 2 of these, but the third and perhaps more abstract one is the origin point. This is one that I can't necessarily see inside of the model. There's some tricks that we can do to kind of make it show up. But otherwise, this is the kind of absolute 0, 0 of the model. And kind of revolving around that, we have 2 additional points. And these are what we typically interact with as users. The first of those is the project base point. And this, or the origin point, are usually the points that we're going to coordinate all of the building disciplines around. So if I have an architectural model and I'm trying to start a mechanical, electrical, plumbing, or structural model, we are going to coordinate those models or link those models together, depending on my standards, either based on the origin or the project base point. Again, how you do that doesn't matter. That workflow is the way it is. Now, the third point that we have inside of Revit is something known as the survey point. And this is how we can assign real-world coordinates to a Revit model. But as I mentioned, the world is flat and it's no more than 20 square miles. So while we do have this facility that allows me to set a real-world coordinate, that real-world coordinate is probably going to be beyond 20 miles from the project base point, or really the model origin. So we need to find a way to sort of navigate and thread this needle. So with that in mind, we're going to use a number of different tools today. Now, as the title implies, we're going to use Revit, Civil 3D, and InfraWorks. InfraWorks will be at the end for the purpose of visualization. But to facilitate the basic construction document workflow, we're going to be using Revit and Civil 3D. Now, the really convenient thing about this whole workflow that I'm going to share with you today is, conveniently enough, neither Civil 3D nor Revit can do what we need it to do out of the box. Pretty convenient, right? So we are going to use a couple of extensions, and the good news is these extensions are made by Autodesk and they're made available to us for free. As long as you subscribe to Revit or Civil 3D, you have access to these extensions. The first is going to be known as the Shared Reference Point extension, and this exists in both a Civil 3D flavor as well as a Revit flavor. Now, above and beyond that, there's another extension, and I know this one has gotten sort of a bad rap over the years, and somewhat rightfully so, but the other extension we're going to use is something known as the Site Designer for Revit. I'm going to use just one function out of that tool, but it's a really important one. And then likewise, to help facilitate a little bit of the exchange between Revit and Civil 3D, we're going to sprinkle in a little bit of Navisworks in here as well. So our basic workflow is going to look something like this. We're going to set up the basic or the base Revit model and kind of clean it up in a way that we can send that over to the Civil 3D user, where they will do some basic cleanup, establish the coordinates, basically place the building on the project site. And then from there, we will then send that Civil 3D file and information back to whomever's managing the architectural model, where we'll do some setup there and work to synchronize the 2 models. And once all of that is done, we have a fully sort of reconciled model where we can exchange information really wherever I want, be it from Civil 3D to Revit or Revit to Civil 3D, or even to a tool like InfraWorks. So this is what we're going to take a look at here inside of today's presentation. So first things first, let's take a look at kind of setting up things inside of Revit. So in this case, this is a basic Revit model that we have set up. And by default, we don't see these points that I'm talking about. That's so critical to today's presentation. So to do that, what we're going to do is display those points. And we could do that pretty easily using visibility graphics. Now, if we go into the model categories, the 2 points that we're interested in are actually under the site group. So we're interested in the project base point and the survey point. And so clicking those on, clicking OK, you'll see here at the sort of A1 corner of my sample building here we see those 2 points. And so those are going to be our really important points for today's presentation. And so once we have those displayed in the model, now we can start setting up the coordination between Revit and Civil 3D. Now, I know you do all sorts of awesome work to make the inside of the building look phenomenal, but on the civil engineering side, we're not so interested in that. We're really interested in the footprint of the building. So with that in mind, we're going to set up a view inside of Revit that's going to more closely mimic that. So first things first, we're just going to create a new view. It'll just be on the first floor. And we're going to try to clean this up in a way that will make it a bit more usable to the civil engineer. Now, to make this a little easier for me inside of Revit, we're just going to call this something like first floor civil coordination. You can name this whatever you'd like, but this is just for your own bookkeeping purposes. And what we're going to do from this particular view is, as we move ahead here, we're going to go ahead and only display what is really pertinent on the civil engineering side. So we're going to hide some stuff basically. Now, once again, this is going to be a task that we will facilitate through visibility graphics. So opening up visibility graphics, we can go ahead and we'll basically click everything, select everything, click off, which will basically hide everything. And then we'll go ahead and display only the stuff I care about. Now, in my case, really what I care about is going to be the walls and maybe some basic annotation here. So we'll go ahead and also come over to the annotation. We'll click off everything here and we'll go ahead and hit apply. And what we'll be left with in this view is nothing but the walls. So this is really good. Now, while this would be kind of nice just to send over to the civil engineer, if we could, it would be really nice to maybe hide the interior walls. Now, unfortunately, with visibility graphics, this is something we can either turn the walls on or off. We can't really designate between interior and exterior. And so for this is where we can leverage things inside of Revit, such as view filters. So once again, over on that view tab, kind of next door to visibility graphics, we have filters. And we can do a lot of really powerful things with filters inside of Revit. So I'm going to go ahead and create a new one here, and we're going to call this walls exterior only. And we'll go ahead and tell Revit to apply that to walls. Now with this, once we've kind of targeted walls, we can now create the logic or the filter rules as they are called here. And my walls have a function applied to them. And what we can do is set up a rule, and it says function is basically equal to exterior. And what this will do is basically filter only the stuff, only the walls whose function is equal to exterior. And we'll hit apply and OK. And set that. Here we go. And once I do, we should see, we need to go into visibility graphics now and apply that filter. So here, once we've created the filter in this view, we'll go ahead and apply that filter to this view. And as soon as I do, what we'll do here is basically set the visibility of exterior only and then hit apply. And we'll go ahead and see that all we're left with now are the exterior walls of this building. So this is a really nice thing that we can then send over to the civil engineer. So with this, what we're going to do is moving on. At this point, we're really ready to get ready for the handoff between the architect and the engineer. And to do that, we're just going to do a very simple export to a DWG file format. So here we are, we're going ahead and we are exporting that. And in this case, we're just going to do the current view. We'll pretty much accept the defaults here because we don't really have any coordinates right now. We'll hit next. And give it a place that I would like to save this. So we'll just go ahead and save this in a basic directory. We can give it a name if we'd like, and select the file format that I would like as well. So with that, we'll go ahead and click OK. And just like that, we are going to have an AutoCAD drawing that we can now bring into Civil 3D and begin doing our work. So with that, let's go ahead and skip ahead here. We've done the very basic setup inside of Revit at this point. Now we need to start doing the work inside of Civil 3D. Now, one of the first things that we're going to do here is take that export that I got from Revit, and we're going to do some very basic cleanup. On the civil side, all I really care about is the absolute footprint of the building. I don't really care about the walls as they are right here. So we're going to do some very, very basic cleanup here, and I'm just going to kind of skip ahead here a little bit so that we can kind of make sure we monitor the clock as best we can here. So this is what I'm going to take the Revit model and simplify it down to, is once again, just the base building. And so with that, once I have this in place, we're now ready to begin placing our building on the project site. Now, through the magic of movies, because I am such an awesome civil designer, I have designed the entire parking lot without knowing where the building needs to go. Obviously, this is a little bit of made for movies here, but what we're going to do is go ahead and take that cleaned up version of the floor plan from Revit, and we're going to go ahead and import that or insert that as a block inside of my Civil 3D model. So with that, we're just going to go ahead and browse out to where I saved that building footprint, and we'll go ahead and specify a base point. Again, we don't have this Revit model geographically referenced just yet, and we will need to specify a rotation angle. So with those two factors or properties selected, we'll hit OK, and we'll go ahead and specify an insertion point of this building. And once again, for the purpose of demonstration, I have planted a couple of points inside of my Civil 3D model where we can now go ahead and place that on my site. Now, something that is maybe a little different from the way that civil engineers will often work for building footprints is this is actually elevated at the finished floor elevation that I would like for this building, which in our case, you can see in the coordinate readout at the bottom is 190 feet. So we have the building placed on the project site. What we need to do now is take that information and sort of export it to a format that the architect can use. Now, this is where the shared reference point tool comes into play, and we will access that inside of Civil 3D from the Toolbox tab. And if you don't see that, up in the Palettes panel in the upper left corner there on the ribbon, you have a little toolbox, and you can turn that on. But once the shared reference point tool is installed under the Subscription Extension Manager node, we'll find a tool called Export Shared Reference Point for Autodesk Revit. And here it's going to ask me for the building location. So we'll pick the origin point. My favorite prompt is a quasi-north, which in the world of civil engineering is sort of an oxymoron. But nonetheless, in the positive Y direction, we'll go ahead and pick that. And what this tool does is it basically takes the point that I selected. It's going to acquire the X and Y coordinate, which X is equal to our easting value, Y is equal to our northing value. It will also pick up the elevation, our finished floor elevation, and a rotation in the XY plane. Now, one important thing we have to do is pick feet, and otherwise it won't come into Revit correctly. But from here, we'll go ahead and save this building location out. We'll go ahead and just save over top of the file I already had, and we'll give it a name, and go ahead and click Save. So with that, we now have this building location. We have placed it on our site, and we have exported all of that information that we'll need inside of Revit to an XML file. And if we take this XML file and we open it up inside of your favorite text editor, Notepad, or whatever you prefer, this is what we are going to see. So once again, the same information we saw presented to us in the dialog is right here inside of the Notepad document. So you'll see that we have an easting of around 11 million feet and a Y coordinate or a northing value of around almost 4 million feet. And finally, we have a finished floor elevation for our project, or an origin Z as it's listed here, of 190. And then we have a rotation in the XY plane. So it's taken all of that information and just exported it out in a way that we are now going to set up our architectural model. Now, I'm going to pause here for just a quick moment, because this is one of the areas where we can have things start falling apart once again. because as I mentioned at the start of the presentation, anything, or the world in Revit is only about 20 square miles, less if you can at all costs here. Our XY coordinate is 11 million, 3 million. That is far beyond 20 miles. And so we have yet another sort of challenge to face here, and that is, how can we, in a managed way, bring my civil site to the Revit model? And this is kind of a little bit of a riddle. We could import the shared reference point directly into the architectural model, but again, we're going to exceed that 20-mile limit. So how can we sort of skirt around this issue? And my solution for this is actually to go ahead and create a new Revit model. So here we're back inside of Revit. I'm going to create a new model. We'll use whatever template you prefer. We'll use architectural in this case. And I'll go ahead and say OK. And from here, what we can do is we have our blank model. I'm now going to link in the architectural model, kind of like I was creating any other discipline-specific model, like mechanical, electrical, plumbing. So here I have my architecture model. We're going to go ahead and link that in. And as I mentioned at the start of the presentation, usually when we're creating these discipline-specific models, we are either doing origin to origin or base point to base point. You can choose which one you want here. Just be consistent across the entire project. Now, for the purpose of today, we're going to assume an origin to origin linking here. And so here, as you can see, we have the architectural model. And we're just going to go ahead and save this. I'm going to call it civil RVT, and we'll just overwrite the file that I already had there. And we now have a civil model created for my project. And so from here, this is where we're going to begin applying those real world coordinates inside of this model. And the net result is going to be that we'll be able to link the civil model back into Revit, and from there, begin importing all of the stuff from Civil 3D. So with that in mind, what we're going to do now is go ahead and import the coordinate that we exported from Civil 3D. Now, as I mentioned, all of this has to relate to points, specifically the survey point and project base point. So if we go ahead and turn that back on, since this is a new model, we'll go ahead and do that and hit OK. And you'll see those 2 points appear right here. Now we want to go ahead and set the actual survey point. And so to do that, this is where we're going to use the shared reference point tool, the Revit flavor of it. And it's over on the add-ins tab. It's the most appealing icon on the entire menu there. And it's going to prompt me for the same things I picked inside of Civil 3D. So starting with the origin point, ending with a positive value on the Y. These 2 points, it doesn't matter where they are. You just need to coordinate with the civil engineer to make sure you pick the same 2 points. But from there, we're going to go ahead and pick the XML file that we exported from Civil 3D. And that is going to bring those coordinates straight here into my Revit model. But if we look at the coordinates there, look at the points, we'll see that nothing has actually really changed. That's because while we've imported the point, we haven't set it as the survey point. And so to do that, we'll go over to the Manage tab under Project Location and Location. That will open up our Location, Weather, and Site dialog. And you'll see on this tab, the building location point that we imported from Civil 3D. We'll go ahead and make that current and say OK. And you'll see that the survey point disappears from the corner there. And while the view doesn't change, we can change the orientation to true north. And here we will see the building sort of rotate for me. And from here, we can import all of the stuff that I need to coordinate between Revit and Civil 3D. And we can also link this model straight into my architectural model using origin to origin or project base point to project base point. The purpose of creating the civil model is once again to, in a managed way, sort of bring the civil site down to the Revit model. So we can sort of manage that 20-mile limitation of Revit while also keeping everything at real world coordinates. So as I mentioned, at this point, we can begin sort of exchanging and synchronizing information between Revit and Civil 3D. So what we're going to do here is inside of Revit, I'm going to go to a 3D view. It doesn't matter which one you have, just go to some Civil 3D view. And to make it so that I can actually see the Revit model inside of Civil 3D, I am going to export this to an NWC or a Navisworks file. This is a lesser known feature of AutoCAD actually now, is the fact that we can import or link in Navisworks model inside of Civil 3D or AutoCAD. Now, I do want to come in here to where it says Navisworks settings and go ahead and change a few things. So first things first, I want to make sure that the coordinates are set to shared, not project internal. The shared is going to be the survey point that we just set, so the real world coordinates. We'll also want to make sure that feet are selected, which I think actually it already was defaulted. We'll go ahead and hit save. And at this point, Revit is going to write out the Revit model as a Navisworks file. So it'll just take a couple moments to do that. And once that is complete, we are ready to begin coordinating things with Civil 3D. So with that, here I am, I'm back inside of Civil 3D. What I would like to do is bring that Revit model into my Civil 3D model in a way that it doesn't blow up. And that was really the reason that we used Navisworks. So what I'm gonna do is just inside of AutoCAD, go to the Insert tab under Reference and choose Attach. And we'll go ahead and pick the Navisworks file that we exported. And since everything is geo-referenced, we can use an insertion point of 0, a scale of 1, and a rotation of 0, just like it was any other civil document at this point. And assuming we did everything right, the building will come in exactly where I located it inside or on Earth. And so here you can see I have the Revit model right here on the project site inside of Civil 3D. And this is all fine and good, but I'd really like this net result inside of Revit. So how can I do that? Well, this is where, and I'll just go ahead and carry on here. If you're a Revit user, you're probably very familiar with the IFC format, sort of an exchange format of Revit data or kind of BIM data, so to speak. We have something similar in the world of civil, and it's called Land XML. Land XML is the sort of IFC of civil. And so every self-respecting civil application out there, be it Civil 3D, be it Bentley Open Roads, will have the ability to export and most likely also import civil or Land XML data. So in my case, I'm going to take the surface for this project. I'm going to export this out to a Land XML file. So we'll go ahead and export that out. And sorry, I'll give it a name like existing ground in this case. And we'll say save. And that is going to write that file out, or write not that file, but just the Civil 3D, the actual tin surface. So the exact surface definition that I have in Civil 3D, we have exported that out to a Land XML format. Now, this is where the Site Designer plugin comes into play, because out of the box, Revit cannot import Land XML. But if you install the Site Designer plugin, I encourage folks to ignore every tool except for the Import Land XML button. So here we're going to go ahead and browse out to the file that we exported. We're going to tell it to look at topo surfaces, and now we will position it based on the survey point that we have established. So that real world coordinate. This is going to show me all of the surfaces inside of the XML file. We just have existing ground. And we can either add a new topo surface, or if this is an updated grading plan, we can actually overwrite an existing topo surface. So it makes the sort of coordination of updating things throughout the purpose of design really, really simple with this tool. But nonetheless, what that's going to do is import my surface. And again, assuming we did everything right, we are going to see the Civil 3D surface exactly as it was defined in Civil 3D now inside of Revit. So again, I find that the Site Designer tool with that Import Land XML, it's probably the easiest way if you're not using a tool like BIM 360 or some of the other tools that Autodesk has recently come out with. I find this is the easiest way. And like I said, if we do put a spot elevation inside of Revit, it's going to be the exact elevation I would have inside of Civil 3D. All right, so This is where I think things start getting really fun and exciting, because we have at this point coordinated Revit and Civil 3D together. And so we've kind of seen how we can export things from Civil 3D and bring those into Revit. Since we've set that shared reference point, we've set the real world coordinates of the Revit model. And likewise, we can export things from Revit and bring those into Civil 3D at real world coordinates. Again, the key pieces here is that we created that sort of discipline model of Civil so that we can manage things, and we'll do the exports from the Civil model. And likewise, we can import things from Civil 3D using things like the Site Designer tool to get the actual topo surface. And certainly you can always link in the CAD file if you need the site layout as an example. But what clients oftentimes really want is to see their project before it exists. And I know we all have various ways that we'd like to visualize things, but one of the ways that I really like is through InfraWorks. So InfraWorks is a tool that will let me do a lot of things. There's some design capabilities inside of it now too. But for the purpose of today's presentation, we're going to take a look at this as more of a presentation or visualization tool. Now, one nice thing about this is, or one really powerful part about InfraWorks is really its ability to communicate what could be in the context of what is. And that's really what clients, and if you need to take a project to a public hall or public square meeting where the public is going to be there, we all know the various terms like NIMBY, not in my backyard. There's also FRUIT. I don't know if you've heard of FRUIT before, but that one is fear of revitalization, urban infill, and towers. And my personal favorite is banana. I don't know if anyone on the call has heard banana before, but banana is build absolutely nothing anywhere near anything. And I'm sure if you've been in this field for any time, you have worked on a few banana projects. And so how can we hedge against this? And I believe it is to communicate in the communicate our proposed project in the context of what surrounds it. And so one of the ways that we can do that in quick order is through using Model Builder inside of InfraWorks. So with Model Builder, if I know how to drive Bing Maps, I know how to create an InfraWorks model. So here we're just going to go ahead and zoom into a location. And again, this is a fictitious site, but it is around the Science Museum of Virginia. And what I'm going to do is just kind of zoom out a little bit to give me that context that I want to communicate. And I'll go ahead and enter a name for this. I'll just call it Science Museum as an example here. And what I'm going to do is create or click Create Model. And when I do that, InfraWorks is going to go out and source road data from publicly available data sources like OpenStreetMaps. The same thing for building data. It's going to use Bing Maps for imagery, and it's going to use USGS sources for the elevations. So I'll hit OK or Create Model. It is going to begin creating that model. And so within about 5 minutes or so, I will get an email from Autodesk saying that my model is ready. And this is where we can now, if we open up InfraWorks once again, we will see that new model that we created with InfraWorks. And we'll go ahead and download that here real quick. So I'm just going to go ahead and quickly download that model. We can fast forward through the download process. And in just a moment, what we're going to see here is the model that InfraWorks has created for me. And again, this is doing nothing more than zooming into an area using Bing Maps, really. So this is what I got with about 5 minutes worth of work, which I think is pretty awesome. Now, that base file is pretty great, but the data that I have for my project is probably a bit more accurate. So this is where I like to begin augmenting that initial sort of Model Builder model that I got by using my actual project data. So I mentioned, or you saw a bit earlier, that we exported our surface as a land XML, and we use that land XML to bring it into Revit. But what I can also do is bring that land XML file straight here into InfraWorks. So we'll go ahead and pick on that. And again, because all of this information is already geo-referenced, what we're able to do is just tell it to import, and it's going to import it exactly where it exists on Earth. Give that a moment to think. And there it is. And if I go over here now, we'll go ahead and tell it to basically display that information. So we are just going to say close and refresh. And when I do, I should see the contours here going through my fictitious site update. So we had a contour going kind of through the center of the site diagonally, and you can see here with my real data that this now flows in a much different direction here. So, and it's also done a good job sort of blending this, which is perfectly sufficient for the purpose of presentations. So we have our real world terrain data on the site. Let's start bringing in all of the other stuff. So the first thing I'm going to do is bring in my Revit model. Now I had, and I didn't actually show this in the previous demonstrations, I did from Navisworks export this as a FBX file, so a 3D model file. InfraWorks does have the ability to import a Revit model straight away. However, it only uses the origin point. It ignores the survey point that I've selected. So for that reason, I will pass things through Navisworks. I will export that to an FBX file, which will just come in as a regular 3D model. Now here, unfortunately, the FBX model isn't going to have any true coordinate data assigned to it, but we're going to classify this as a building. And I happen to know that the coordinate system that I used was the Virginia State Plains South foot North America datum of 1983, which the code for that is VA83SF. So we can go ahead and basically assign that coordination or coordinate system if I happen to know it, and I do. So we're going to say close and refresh. And when I do, we're going to see the building appear exactly where the civil engineer placed it on the site, just like that. So really awesome there. So with that, this is where we can then begin importing all of our various site layout. So what I have done is from Civil 3D, I have exported the various areas, my parking lines, all of the sort of site design. I have exported those as an SDF file, which is a sort of Autodesk GIS format. And we're going to bring those in as coverage areas and basically apply materials to them. So first is the project, sort of the site boundary or the parcel boundary. I'm importing that. I'm going to go ahead and just give it a material of tall grass so that we can see what that looks like. And InfraWorks is going to think for just a quick moment. And we are going to see kind of my project site kind of blinked out, so I don't actually see the existing imagery underneath of that here. From here, we can begin importing the other pieces as well. So here's my parking. We're going to go ahead and make that a coverage area as well. And for the material, we're going to go ahead and choose kind of an asphalt color. So we'll do black asphalt and hit close and refresh. And this is going to show the pavement of my site. And so this is the parking layout that I saw. We're going to go ahead and import a few other things. So here I have my parking islands. So we're just going to overlay that on top once again as a coverage area. And I'm going to apply a material of regular grass here. So we'll go ahead and do that and bring that in. And again, you can start seeing this project take shape here. So here I have largely what I had inside of AutoCAD now presented to me inside of InfraWorks. The final piece that I'm going to bring in will be my parking lot lines or parking stall lines. For this, we'll just go ahead and apply a color of white and hit close and refresh, and we will see all of the pavement markings appear for me inside of the site as well. So again, with maybe 10 minutes of work here, I have visualized the entire project site in the context of its surroundings. And so I can spin around with it very fluently, and I can begin answering the questions of what does this project look like from my backyard? Now that's really great, but let's kind of take this a step further. And so, whoops, I duplicated that. This is kind of a flat site right now. And while that looks nice, it looks basically the same as what I had inside of AutoCAD. I'd like maybe to show some landscaping and some other sort of site features on this project, and we can absolutely do that as well. So one of, I think, the other advantages of InfraWorks over maybe what seems like a similar tool like Navisworks is the fact that we can actually create things in here as well. So it's not just about aggregating data. So as an example, we can create a row of trees. So I'll do a row of trees. I'll pick a tree that I like. I like the T19 tree, light green. Again, you can pick what suits your fancy, but I'm just gonna put some basic trees in here to kind of give this site a little bit of depth here. And so we'll go ahead and just plant those trees kind of quickly here. And you'll probably start seeing why I am our design technology manager and not in our landscape group. They will do a far better job at planting here. But nonetheless, we can begin placing those trees into our project site here, and you can see things starting to take shape. And so really easily done here. Let me just sort of fast forward a little bit. Here you can see I have placed some of the additional trees. I'm going to go ahead and put some trees in each of the islands as well on the site, just to kind of give it a little bit more depth and relevance here. And then I'm also going to take this a step further. And let me continue on. Actually, I'm going to go back here a little bit. Something else we can do is place what's called city furniture inside of my Revit model. So I'm going to go ahead and place some cars here as well, just to kind of give this a little bit more to it. And so here, if I go ahead and pick a car, we'll go ahead and place those. And if I kick this into 3D again, you can start seeing this view. Now, right now the view is pretty flat, but if I change it from the sort of low fidelity engineering view to a conceptual view, this really starts looking good with realistic sun shadows. We have a moving sky assigned to it as well. And we can, of course, render from this as well. And so this is, I think, a phenomenal way to begin communicating our projects a bit more effectively. And it's all centered around first coordinating my Revit and Civil 3D models together through the workflow we showed at the very beginning. So with that, to kind of begin wrapping up here, just to kind of quickly recap what we have done today. So we've gone through quite a bit here. And one of the first things we did was set up sort of the Revit environment here a little bit. So we took a look at the coordinates, we simplified those civil views, and we exported the Revit sort of base view as an AutoCAD file that the civil engineer then brought into Civil 3D and did some basic cleanup. Now, the essential task that the engineer did at this point was place the building on the project site. So they figured out the northern easting of it, as well as the finished floor elevation. And this is the part that, or kind of one of the first big tripping points in kind of project coordination is how do we communicate that information from the civil design into the Revit design? And that's where we use the shared reference point tool to export that information in a way that once we installed the same tool inside of Revit, that we were able to import that into Revit from there. So you'll recall that basically in step 4 here in the process, kind of the workaround that we applied to hedge against the 20-mile limit of Revit was we created a civil model that we linked in with origin to origin, or however you link in your other discipline models. And we basically defined the survey point in that model. And that allowed me to basically have the flexibility of linking in a civil Revit model without exceeding the 20-mile limit in my other models. Once everything is synchronized up, this is where I think the real fun begins, because we can begin exchanging the Revit model into Civil 3D. We can also begin taking those kind of critical elements from the civil design and export them in a format that Revit can read. And you might recall that the big thing that we used in that coordination was the Site Designer add-in that we can get free from Autodesk. And it allowed me, while I think a lot of the tools aren't so useful, the one that is super useful is the Import Land XML tool, because that will allow me to import the exact surface as it exists in the civil model into Revit. And that really got us to the point where we had a fully sort of coordinated model between Revit and Civil 3D. And then we could really start playing with things and having a lot of fun by visualizing inside of InfraWorks. So that is the process. I know we went pretty fast there, but as Sarah mentioned at the start of the presentation, this presentation is recorded, so you can absolutely refer back to it afterwards as well. Sarah, I'll kind of turn it back over to you real quick.
Absolutely. Great information, Donnie. As we wait here for any questions to roll in, I got one for you here. Does the shared reference point extension work with basic AutoCAD or AutoCAD Map 3D?
Good question. And so this is kind of the fragmentation of AutoCAD. It really kind of spotlights that a little bit. So AutoCAD has a number of different flavors associated to it. And unfortunately, the simple answer to the question is the shared reference point extension is something that's exclusively available to Civil 3D. So you will need Civil 3D for that. Even though Map 3D understands coordinate systems and all of that, it doesn't kind of have that extension. Now, the good news is if you're trying to do this coordination without Civil 3D and all you have is AutoCAD or Map 3D, we can manually query those coordinates and we'll have to manually input those into Revit. So it's a little bit more of a clunky workflow. The shared reference point tool really just sort of automates that process a bit and makes it a little easier, but the coordination can still happen. It'll just be a more manual workflow.
Okay. Is it possible to get the information modeled in Civil 3D, like other than the ground area, to show up in the Revit model?
So yes, and I guess, I'm guessing part of the question here is going to relate to things like the pipes inside of a project. So if you've worked with civil drawings before, you probably know there's a couple of rules. First, we need no less than 1,000 to 1,500 layers in our drawings, sorry. But above and beyond that, pretty much all of the site layout pieces are going to be at an elevation of 0. The stuff that we're going to model in 3D or something that can be output in a 3D format is going to be our surface and our pipes. Those are kind of the two big things that we are going to model in 3D. I didn't show the pipe piece, but since that is in 3D and we can import and export things back and forth between Revit and Civil 3D, we can absolutely show that information. To get the site layout, since that is at elevation 0, that's where I would just link the CAD file in. I would link, not import, and so you could kind of at least see the layout. It wouldn't be in 3D, but you could at least see it. So maybe I went a little beyond
okay. Once the new site model is created in Revit and the ARC model linked correctly, can the same site model host multiple building models for phased or campus projects?
So the multi-building scenario is a challenging riddle. So what we're going to have is one shared reference point. And so if we coordinated things around kind of one master building, we could have one sort of civil model that kind of ruled them all and went from there. I would still probably need some sort of pass-through model though to orient the architectural piece into civil. So I know this is kind of a hard one to kind of talk through here. But you'll recall that when we use the shared reference point tool, we picked 2 points inside of our Civil 3D model that was specific to that building. And that is telling or kind of capturing where does that building exist. Usually there's not a direct correlation that the building next door to it is the exact same rotation or some relative rotation to that other building. They can usually kind of move and rotate independently of each other. And so with that, what you may need to do is actually have multiple civil models, one for each building. The good news is once all of those models are referenced in a geographic coordinate system, you can link all of them together through the survey point at that point. So you might have to do kind of a couple different sort of pass-through models. It can be done, but it gets a bit more complicated.
All right. Is Site Designer still available for 2021 Revit? And if so, if not, is there a way for 2021 products to use Land XML?
So this is a good question. I'm not exactly sure of the answer of it just yet. So the 2021 products from Autodesk just came out within the last 2 or 3 weeks. And so the hero products are out: Civil 3D, Revit, AutoCAD, kind of name all of the products. They are all now on the street. In previous years, what I have found is that the shared reference point extension and the Site Designer extensions don't get released at the same time as the hero product. We usually have to wait a couple of months for them to release those. I haven't heard anything about Autodesk discontinuing the Site Designer add-in. I likewise haven't logged into the Autodesk account site to see if it exists. I'm trusting that it doesn't exist just yet. But my expectation is that it will be released within the next couple of months. I haven't heard anything to the contrary. If it doesn't get released for some reason, the alternative workflow that we can do to basically mimic the XML is have the civil engineer export their AutoCAD drawing or Civil 3D drawing with the tin or triangulated irregular network displayed, and in Revit actually build the surface from the actual triangles that Civil 3D is building, not the contours. So at all costs, I would try to avoid building things from contours and build them from the tin lines instead. And so a workaround would be just to go back to the basic drawing format approach to that.
Very good. Has Revit always had the capability to export only certain items like the exterior wall as a single block?
So we've always had view filters, at least for a really long time, inside of Revit. I forget the release. They all kind of start running together for me. We did finally get an OR parameter. So for many years, Revit, when we created the view filters, was only an AND parameter. So it had to qualify for all of the rules that you applied to that particular view filter. Again, I forget the version, but we also got an OR. So you could do, it's not necessarily applicable to this scenario where we only wanted to show exterior walls, but maybe I was trying to filter something else inside of a view. I can't even think of something off the hand, but if I wanted, exterior walls or load-bearing interior walls, let's say, if I had that category or classified as part of the parameters of the Revit families, we could do an OR parameter and kind of see both. But the simple answer to the question is yes, view filters have existed in Revit for quite some time.
Can you go back over how you exported the parking lot in InfraWorks? Parking lot to InfraWorks.
Right, the parking lot to InfraWorks. So what I did there, I didn't actually demonstrate that. And I know we're kind of bumping up on time here. Let me see if I can actually get Civil 3D open here. So what I did, and I will just quickly open up my Civil site drawing here inside of Civil 3D. So actually, I don't think this drawing has it set up just yet. But what I did is I created a closed polyline of the entire parking lot area. And so if I basically came in here and I did select similar, and I will just isolate that real quick. What I did here, whoops, I need to also get the curves as well, or the arcs in here. So let's do this, and I will do, whoops, select similar, and we will do isolate. So what I did was I basically came in here and I did a line right here. Here we go, we'll just do this. Of course, I'm doing this. Let's do it this way. So I basically just created a closed area as a polyline, and I missed a bit over here, but that's okay for the purpose of what we're doing here. Make sure this is all watertight. And if I create a closed polyline out of all of this, and I'm sure it's probably not going to close because I'm doing this live, and of course it did not. I did have some flaws in the geometry here. But what I'm going to do is once I do get the closed polyline, it's not entirely closed, and I'm just going to force it to close real quick. What I did is actually I turned to the Map 3D functionality that we do have inside of Civil 3D. And inside of the Map 3D sort of workspace of Civil 3D, we have the ability to export things to a GIS format. And that's what what InfraWorks is going to want and need. So if I come over here to output, we have this command right here, which is drawing to SDF. SDF is Autodesk's shapefile format, you can think of it as. And what we can do is basically, I could do parking. There we go. Let's save it to the desktop for right now. And I will just pick the line work that is closed. In this case, I will just export that out to an SDF file, and that SDF file is what I was importing into InfraWorks. So I didn't have the video there. I did kind of skip over that, but that is how you do it.
Very good. Well, you officially did it. You answered everybody's questions for today. So I want to thank you for all your information you provided. I want to thank everybody for joining us today for this webinar. Just a quick reminder that we will be sending out the certificates to all the attendees via email, so be on the lookout for that. And feel free to register for any of our other webinars coming up. We have them weekly. You can go on to our website at www.timmins.com and register for more. Hope everyone has a great rest of the day. Thanks, Donnie.
All right, thank you.
Bye, everyone.